The history of the Earth begins with the first seconds of its formation. It has been unfolding for almost 4.6 billion years, marked by massive extinctions, catastrophic episodes, but also periods of stability. The Earth never stops evolving, mysterious blue planet of the universe. It is the only one known today to shelter a human life form. Here is a look back at its accretion and evolution. In order to represent more easily the timescale, the values of billions and millions of years are reduced to 12 hours, i.e., one turn of the dial. The accretion of the Earth occurs at 12 a.m., and the year 2022 is represented by 12 p.m. During these 12 hours, we will cross 4 chronological periods: the Hadean, the Archean, the Proterozoic, and the Phanerozoic. Dear traveler, good morning. Today we will go back in time to discover the mysteries of the formation of our planet and all those incredible phenomena that make our Earth so unique. Before leaving for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. The first period is the Hadean, which lasts 500 million years and is the oldest division of geological time. This is where the 12-hour clock starts. 12 a.m. The accretion of the Earth. 4.54 billion years ago, the accretion of the Earth begins with the formation of the Sun. A few million years earlier, the gravitational collapse of a tiny part of a molecular cloud made our star appear. A disk of gas and dust forms around the young celestial body. These grains slowly clump together until they form small solid bodies, the first fruits of planets in the making, the planetesimals. Under the effect of gravity, these planetesimals reach up to a few kilometers or miles in diameter, eventually forming embryos of planets while ridding the disk of its original dust. The farther the objects are from the Sun, the more massive they are, since they find more material to agglomerate along their path. After a certain distance from the Sun, the planets are able to attract the gases of clouds made of hydrogen and helium until they collapse on themselves, giving birth to the gas giants that we know well, Jupiter and Saturn. Uranus and Neptune being smaller, they do not keep the gases, but only their core of rock and ice. The planets that form closer to the Sun are called telluric. They are composed of rocks and metals. They are violently struck when their orbits cross to such an extent that only 4 remain: Mars, Venus, Mercury, and Earth. The formation of all these planets lasts 100 million years. (12:06 a.m.) The formation of the Moon. Theia, a protoplanet, wanders in a stable zone of the cosmos, at the same distance from the Sun as the Earth. As it reaches the size of the planet Mars, Theia is destabilized by the gravitational influence of the other planets. Its orbit becomes chaotic, and it violently collides with the young Earth in formation 4.52 billion years ago. The shock is so violent that the iron core of Theia plunges into the heart of the Earth. The rest of the planet and part of the Earth's mantle are ejected into the cosmos. All these materials in orbit around the Earth eventually gather and give birth to the satellite that is the Moon, some 22,500 kilometers or 14,000 miles. The Moon stabilizes the Earth's axis of rotation and slows down this same movement by the phenomenon of tidal friction, which explains that at this time a day lasts only 6 hours and that a year counts 1,434 days. 12:22 a.m. The formation of the Earth's crust. 60 million years after the formation of the Moon, the surface of the Earth undergoes important impacts of bodies of modest size, which cause a release of heat. This kinetic energy is transformed into thermal energy. Radioactive elements, such as potassium or uranium, still little disintegrated, also produce heat, which is added to that resulting from collisions. The initial Earth is very hot. Unable to evacuate this heat, it is stored, melts the rocks, and forms an ocean of magma. While it was until now quite homogeneous in its physical and chemical structure, the Earth begins to distinguish itself. Iron and nickel, the heavy elements, sink to the bottom of the magma ocean and accumulate at the center of the planet under the effect of gravity, giving birth to the metallic core. The silicates, lighter elements, remain on the surface, shaping the Earth's mantle. Little by little, the magma on the surface of the Earth solidifies, and the crust is formed on the mantle. From 1 to several tens of kilometers, or half of thickness, it cracks in places and separates into plates. These are the future continents. The mantle remaining liquid, the crust can drift like a raft on the magma. 10 million years pass, and now, inside the metallic core, movements cause electric currents, which themselves induce a magnetic field, which is maintained by providing an electric field. This immense magnetic shield that is formed protects the Earth from the solar wind, which is harmful to life. The latter blows light elements such as hydrogen, nitrogen, or water away from the Earth. Thanks to the shield, the atmosphere is maintained, and the first life forms are protected from ionized particles. 12:54 a.m. The beginning of the formation of the oceans. 4.4 billion years ago, the Earth is slowly cooling. Its solid surface is covered with craters, mountains, and volcanoes. This landscape is fertile. Like an Earth that spits and coughs, the volcanoes release gases and water vapor contained in the magma. Until then, the temperature was so high that water could only exist in gaseous form. It slowly decreases to 350 degrees Celsius, or 662 degrees Fahrenheit, and combined with very high pressure, the vapor condenses and turns into rain. The very first rain on Earth, a torrential downpour. Billions of water molecules from the atmosphere become liquid and fall in a torrent. The water invades the rocky landscapes, trickles down the craters along the mountains. This accumulation of water in the low areas of the relief covers the surface of the Earth and gives birth to the first lakes and oceans, the total volume of the oceans will be formed in 50 million years. The next major period is the Archean, which lasts 1.5 billion years and is generally associated with the appearance of the first life forms on Earth. 1:10 a.m. The Great Late Bombardment. 4 billion years ago begins a long period during which meteoric and cometary impacts see their expansion. It is called the Great Late Bombardment. In cause, the giant planets, Jupiter, Saturn, Uranus, and Neptune, see their orbit reorganize, which results in the destabilization of the orbit of some planetesimals of the external solar system. Some of them turn inwards until they collide with the telluric planets. Impact craters mark the surface of the Moon, Mars, Mercury, and the Earth. These violent collisions have major consequences, especially for the Earth. It is hit by asteroids that can reach the size of a country like France, or 1,000 kilometers, or 620 miles. The energy released during the impact vaporizes part of the oceans. 1:57 a.m. The appearance of the first forms of life. Water in its liquid state is essential for the appearance of life on Earth. A living organism needs energy, such as solar energy and water. The Earth offers a favorable environment so that simple organic molecules react chemically together and evolve into complex molecules like a living being. At that time, the solar energy emitted is 20 to 30% lower than today. If the atmosphere of the Earth 3.8 billion years ago were the same as today, our planet would have frozen in a few hundred years. The lower intensity of solar radiation is largely compensated by an atmosphere loaded with greenhouse gases. The sun being colder, life is less developed. The carbon dioxide is little used and precipitated in the form of carbonate, and oxygen is almost non-existent. The absence of vegetation has the effect that the composition of the atmosphere is 10 to 100 times richer in CO2 than today. The absence of oxygen leaves methane, CH4, in this form for a longer period of time, since it is not transformed into CO2. It is very present in the atmosphere. Thanks to the significant presence of greenhouse gases, the Earth has a temperate climate. Despite a cold sun, liquid water is present on the whole globe. The stage is set for the first cells to enter the scene and the oceans to host the first bacteria. Numerous cyanobacteria, or blue-green algae, nestled in the coastal areas between the extreme limits of the tides. At that time, the terrestrial landscapes strangely resemble those of the moon Titan of Saturn of today. (3:01 a.m.) The appearance of oxygenic photosynthesis. The numerous cyanobacteria are able to fix the CO2 that fills the atmosphere by building stromatolites. These calcareous constructions, in the form of piled-up undulations or clusters resembling cauliflower, are marked by living beings. Able to carry out photosynthesis, i.e., to capture CO2 and to release oxygen, these organisms cause an imbalance in the chemical reactions and precipitate calcium carbonate. The fine accumulation of particles are shaped into stromatolites in the form of carbonate sheets. 3 microbial communities compose the stromatolites: cyanobacteria on the surface, photosynthetic bacteria in the middle layer, and anaerobic bacteria in the lower layer. The first living organisms appear in the water. The Earth's atmosphere is devoid of oxygen. They use solar radiation, a light, and ephemeral energy to transform water and CO2 into carbohydrates, a storable energy. This transformation generates a waste product, oxygen, O2. 3.5 billion years ago, the latter is very harmful to living organisms. Certain organisms thus adapt until incorporating this waste in their metabolism. The first oxygen molecules formed do not immediately accumulate in the atmosphere. They first react with the iron contained in the water and form iron oxide, which remains limited to the liquid medium. It is only a billion years later, once the oceans are saturated with iron, that oxygen will begin to accumulate in the atmosphere. 4:01 a.m. The formation of the first continents. The construction of the continents begins underwater. The subaerial emergence of the first continents is associated with the initiation of plate tectonics. 300 to 400 millions of oceanic activity allowed the construction of an underwater plateau, a progressive pile of lava, which reaches up to 50 kilometers or 30 miles thick. Because of the weight of this plateau, it remains sunken in the upper mantle. Subjected to the laws of isostasy, the mantle tends to rebalance itself and pushes the less dense plateau upwards. 4:20 a.m. The Pongola Glaciation. The Earth has a warm to temperate climate because the atmosphere contains high levels of methane and carbon dioxide. A decrease in these levels leads to a decrease in the greenhouse effect and an ice age. The Pongola glaciation is associated with changes in sulfur isotopes, which implies an early and stealthy oxygenation of the Earth's atmosphere. Together with the Archean and Hadean, the Proterozoic represents 85% of the Earth's history. This very long period will see the birth of the first multicellular life forms and the first animals. 2 billion years have passed since the formation of the Earth. A day lasts a little more than 12 hours, and a year has 714 days. During the formation of the Earth, the chemical elements separated or concentrated, some in the metallic core, others in the lithospheric mantle. The plate tectonics that took place provided new temperature and pressure conditions that allowed specific minerals to thrive. 1,500 minerals are present in the Earth's oldest terrains. The production of oxygen by the living organisms present offers new conditions to the minerals. Those that outcrop on the surface of the Earth are oxidized, a key step in the mineral world, as 2,900 new minerals appear. Living organisms also produce specific minerals. Eventually, 4,400 minerals will cover the Earth's landscape. Plate tectonics is changing. Until then, the Earth's surface was shaped by horizontal, but also vertical movements. Comatites, hot magmas, are set up on the Earth's crust, cooling and becoming denser on the surface. Due to gravity, the magmatic rocks sink and form vertical structures. 2.5 billion years ago, the comatites disappear, and so does the vertical tectonics. Only horizontal movements remain, and the Earth now produces a different type of rock. 6:39 a.m. Oxygen spreads in the atmosphere. The concentration of oxygen has been slowly increasing for a few million years due to the emergence of life. It was, however, present in minute quantities. 2.4 billion years ago, the Earth experienced a peak in oxygen concentration in the atmosphere, the Great Oxidation Crisis, or oxygen catastrophe. The concentration of oxygen increases from 0.001% to about 20%. Until now, the oxygen resulting from the photosynthesis of cyanobacteria reacted with the iron in the oceans, accumulating neither in the water nor in the atmosphere. Now, the marine iron is depleted, the oxygen settles in the seawater, and then reaches the atmosphere. This is a decisive ecological crisis that has an impact on anaerobic organisms. Moreover, oxygen reacts and oxidizes atmospheric methane. The concentration of methane drops drastically. The decrease of greenhouse gases in the atmosphere causes a cooling and a succession of glaciations. It is the snowball Earth. 5:26 a.m. to 6:26 a.m. The Great Glaciation. Life cools the climate and leads to a succession of periods of glaciation and deglaciation. 2.4 billion years ago, the Earth experienced its first ice age, which was also the longest in its history. The surface of the Earth is entirely covered with ice, hence the name, Snowball Earth. With the appearance of life, oxygen also appears. At the same time, the CO2 is trapped in the limestones in formation, what generates a lesser presence of it in the atmosphere. The reduction of the greenhouse gas leads to a decrease in temperature. Remember that at this time, the sun provides only 85% of its total energy. It is up to minus 50 degrees Celsius, or minus 58 degrees Fahrenheit on Earth, for a few tens of thousands of years. The water is frozen. The albedo increases, since the solar energy is more reflected on the white and icy surfaces. The freezing is accentuated. The Earth looks like a ball of ice. Although this situation seems catastrophic and irreversible, the Earth's inner layers remain active. The volcanoes emit CO2, which accumulates under the ice, until the day when the Earth becomes disruptive. This CO2 is then released into the atmosphere, accentuating the greenhouse effect and warming the planet. This is followed by a period of deglaciation that lasts a few tens of thousands of years. This phenomenon of successive glaciation and deglaciation occurs 4 times over a period of 300,000 million years. 6:11 a.m. to 7:46 a.m. The formation and disappearance of the Columbia continent. The Earth is a sphere. Its tectonic movements have as a consequence to modify the architecture of the continents. The ballet of the plates, called Wilson's cycle, takes place under the effect of the tectonic forces. The continents are frequently united in supercontinent and then fragmented. About 2.2 billion years ago, the primitive continents coalesced into a supercontinent called Columbia. It is about 12,900 kilometers, or 8,000 miles from north to south, and 4,800 kilometers, or 3,000 miles at its widest. 600 million years later, Columbia begins to break up. A continental rift forms and expands, accompanied by magnetic activity. The continent disappears completely after a few 100,000 years, 9:06 a.m. to 10:01 a.m. The formation and disappearance of the supercontinent Rodinia. 1.1 billion years ago, the supercontinent Rodinia is formed from the various remaining fragments of Columbia. Resulting from the collision between two continental blocks, the ancient part of North America and South America, this supercontinent is composed of almost all the continental plates of the time. Surrounded by an ocean, Rodinia looks like a large rust-colored desert plain in which sands accumulate. Numerous sedimentary structures and biological constructions like stromatolites are in place. Life has not yet emerged from the water, since the atmosphere does not contain enough oxygen to develop the ozone layer. After several 100 million years, Rodinia breaks up into different continental masses because of the internal movements of the Earth. The continental masses of the Earth are constantly moving, sometimes grouped together, sometimes separated. During the formation of supercontinent, the internal heat of the Earth can only evacuate by conduction, which is not very efficient. It then accumulates, leading to an increase in temperature of both the upper mantle and the lower crust. The density of the rocks decreases. They rise to the surface, adopting the forms of domes that crack and let the magma spread. 850 million years ago, a superdome is formed. It cracks and lets the lava rise up, setting up collapse trenches. After a few million years, water fills the trenches, which forms new oceans. 10:06 a.m. to 10:20 a.m. Glaciation on Earth. 750 million years ago, Rodinia disappears. The small fragments from the former supercontinent are found near the equator. The temperature decreases, and large icy surfaces extend. These surfaces reflect more the radiation emitted by the sun than the darker oceans, and the cooling increases. The Earth freezes over a kilometer thick. It becomes a snowball Earth. Life finds refuge at the bottom of the oceans, thanks to the particular properties of water. As the temperature of the water decreases at the surface, down to 4 degrees Celsius, or 39.2 degrees Fahrenheit, its density and volume increase. It forms a current and sinks, ensuring the homogenization of the temperature over the entire depth. When the temperature drops below 4 degrees Celsius, or 39.2 degrees Fahrenheit, the ice on the surface will form a thermal shield. Even during extremely cold periods, the bottom of the water, lakes or oceans, does not freeze, which allows some living organisms to survive. Life remains confined to the water. The molecules that make up living matter are photosensitive. They could be destroyed if they were subjected to certain radiations, in particular, ultraviolet rays. 600 million years ago, ozone was formed and accumulated naturally in the stratosphere. This molecule, composed of 3 oxygen atoms, O3, absorbs ultraviolet rays, thus protecting living organisms from their harmful effects. At that moment, a first concentration threshold is reached, forming the ozone layer, which has repercussions on marine diversity. Favorable to the development of life when it is located beyond 15 kilometers or 9 miles of altitude, the ozone is particularly oxidizing and dangerous if it is in the air which surrounds us. 10:24 a.m. to 10:34 a.m. The formation and disappearance of the supercontinent Pannotia. A new supercontinent is formed following violent collisions, Pannotia. It breaks up a few million years later during an active phase of plate tectonics. This breakup, like all the others, is conducive to the diversification of species. This is how the marine fauna of the Ediacaran developed. Multicellular organisms with soft bodies appeared around 585 million years ago. Without a mineralized skeleton, their form is very varied and extraordinary to the point of benefiting from a specific name, the Ediacaran fauna. These organisms look like discs, tubes, or fluffy bags. Only 100 species have been counted. This first emanation of diversification of pluricellular organisms is of short duration, since they will disappear 40 million years later. The Phanerozoic is a much shorter period than the previous ones. It still continues today. On our clock, there is less than an hour and a half before our present. What is going to happen in this eon is of major importance for man, and yet it represents only a tiny part of the history of the Earth. 10:34 a.m. Cambrian explosion. The first multicellular beings. 541 million years ago, large quantities of multicellular organisms suddenly appeared in the space of a few million years. Entirely new forms gave rise to the great metazoan phyla and to a great diversity of animal, plant, and bacterial species. One of the characteristics of species at this time is the appearance of hard tissue in the form of mineralized skeletons. Small fossils with shells are found, responding to a need for protection against possible predators. An ocean, Iapetus, which separated the continent Baltica from the continent Laurentia, closes under the impulse of plate tectonics. A mountain chain rises 530 million years ago, a gigantic mountain complex called the Caledonian Chain. It rises in the place of what is today the north of Europe and America and is subject to strong erosion. The lands of Canada, Newfoundland, Greenland, Scandinavia, Scotland, Brittany, and the Ardennes are at this time very close. The Moon is located at 360,000 kilometers from the Earth. 30 million years later, the ocean tides are frequent and powerful. The sea withdraws very far and greatly invades the continents. Life was until then contained in a liquid medium. A decisive evolution takes place 480 million years ago. From then on, plants resembling lichens and mosses settled on land. They adopted strategies to resist desiccation. Some are capable of revival. Others are adorned with impermeable cuticles that allow gas exchange while limiting water loss. These plants cling to the rocks thanks to spikes. They provide the raw material for the degradation of microorganisms. 10:49 a.m. Ordovician Silurian extinction. 445 million years ago, the Earth underwent its first great crisis of life. During the Ordovician, which lasts from 485 to 443 million years before our era, the temperature of the oceans drops by 15 degrees Celsius, or less than 59 degrees Fahrenheit. Life could not flourish in an environment of 45 degrees Celsius, or 113 degrees Fahrenheit, but was delighted with the new condition, and the oceans, at around 30 degrees Celsius, or 86 degrees Fahrenheit, became the scene of a multitude of species. New groups appear, while the existing ones diversify. Around 445 million years ago, a major cooling occurs, accompanied by the installation of an ice age. The glaciation causes a drop in sea level and the disappearance of shallow water areas that were a place conducive to the development of life. This event, which lasts around 10 million years, leads to the disappearance of many marine species, especially benthic species remaining on the seafloor. The duration of a day is 22 hours. 400 million years ago, a second threshold of oxygen and ozone is reached, leading to the exit of the waters of the first terrestrial arthropods that gradually settle on the continents. This is possible because the plants that preceded them offered them the food necessary for their development. Once out of the water, animals must move to find food and develop a mobility strategy. They have an internal vascular system and hydrate themselves by eating or drinking water. Reproduction remains dependent on the aquatic environment. Plants that produce seeds, spermatophytes, develop slowly around 390 million years ago. The elements ensuring reproduction are no longer the spores, but the gametes. The seed allows the transport of reproductive elements and ensures the propagation of the species. This is an upheaval in the world of botany, since the reproduction of plants is freed from their dependence on water and becomes aerial. An extinction episode occurs in Devonian due to a major cooling. The areas far from the large continental masses are affected by a lack of oxygen. The multiplication of plants consumes a lot of carbon dioxide for photosynthesis, causing a drop in temperature and anoxia in marine environments. 75% of marine species and almost all the reef environment disappear. 11:03 a.m. Beginning of the Carboniferous. Beginning of the Carboniferous period, characterized by the deposition of large layers of coal. The continental masses join together. The first large trees appear abundantly, and a great variety of plants are perpetuated. Brachiopods develop, and we find large amphibians and the first reptiles. 11:12 a.m. End of the Carboniferous. The appearance of new species of lignivorous fungi causes the degradation of all the lignin and the end of the formation of coal. 11:12 a.m. The formation of Pangaea. Pangaea, a supercontinent, is formed from the collision of Laurussia and Proto-Gondwana, which had previously grouped all the land masses. Almost all the lands integrate Pangaea. The supercontinent takes the shape of a sea and presents a vast mountain range in its center. It is surrounded by a huge ocean called Panthalassa and holds in the hollow of its crescent the ocean Tethys. The formation of Pangaea has repercussions on life, since the surface area of coastal waters, which had previously been home to many marine species, is reduced. The lands of central Pangaea become desert due to their distance from the seas and the decrease in the frequency of rainfall. 258 million years ago, the Earth experienced exceptional volcanic eruptions that disrupted the living world on a planetary scale and had a major effect on the climate. The current Mount Emei in China emits lava flows covering 330,000 square kilometers on 1 to 2 kilometers or half thickness. A large amount of CO2, water vapor, greenhouse gases, and sulfurous gases are released. Sunlight is attenuated due to the particles emitted. A drop of temperature precedes a brutal warming linked to the emitted gases. 11:20 a.m. End of the Primary Era. Great crisis of the Permian Triassic. A major volcanic eruption occurs in present-day Siberia. Accumulated with the eruption that occurred 6 million years earlier, as well as the consequences of the formation of Pangaea, the effects are catastrophic on life. This Permian Triassic crisis is the most notable that the Earth has ever gone through. It is called the Great Extinction. On the continents, 70% of species disappeared, and in the oceans, 95% of marine species disappeared. All groups are affected. Some are eradicated, like trilobites or unicellular marine microorganisms. Others are decimated like sea lilies, ferns, or brachiopods. From then on, biodiversity evolved differently. 230 million years ago, the reign of the most famous fossil animals, the dinosaurs, slowly begins. Characterized in large part by their extraordinary size, the dinosaurs are very diverse. They have been around for 200 million years and can be found on all continents, in many different forms. The majority are terrestrial, but some are flying, bipedal, quadrupedal, carnivorous, or herbivorous. The biggest ones weigh up to 100 tons, and others, like the Microraptor, are the size of a chicken. They developed all sorts of skeletal and integumentary innovations, such as horns, crests, and feathers. Archosaurian reptiles were the first to occupy the ecological niches vacated during the Permian Triassic extinction, accompanied by herbivores that joined them quite early. At the same time, a salt crust takes shape over present-day Europe. The oceans frequently flooded the land without relief and left salts which over the years accumulated up to several hundred meters thick. Since salt is lighter than most other rocks, it tends to rise to the surface through the different geological layers. When a mountain range is formed, the levels that contain salt, which is more malleable, are deformed first, and when the layers of land move, the salt will position itself to form the footing. It thus gives a particular structure to the rock, which will trap water oil or petroleum more easily. A meteorite falls towards the Earth. As it enters the atmosphere, it fragments and hits the planet in a burst of impact over a period of several hours. A very violent shock occurs at a speed of about 20 kilometers per second, or 12 miles per second, which leaves behind a crater of 21 kilometers, or 13 miles in diameter, and modifies the rocks in their depths. Impact craters are currently found in Canada, France, Ukraine, the United States, and St. Martin. 200 million years ago, the Rochechart meteorite, which impacted France near a shallow water coastline, triggered an 8.2 magnitude earthquake and generated a major tidal wave that washed over land up to 1,300 kilometers or 800 miles. 11:28 a.m. Triassic-Jurassic extinction. Pangea, which has begun to fracture, breaks up, separating North America and Africa. Two new supercontinents are formed, separated by the Atlantic Ocean, Gondwana and Laurasia. The Earth evolves from a strongly western climate to an oceanic climate. New oceanic ripples are activated and cause the rise of the sea level. New continental surfaces are submerged. Biodiversity can flourish again. Because of the separated lands, the possibilities of reproduction and genetic exchanges between individuals are limited. Populations become species in their own right on each of the two continents. This reshuffling of the continents causes the reduction of biological diversity through a massive extinction, since nearly 20% of marine species and a large part of terrestrial vertebrates disappear. This Triassic-Jurassic extinction allows other species to emerge within a few million years. The dinosaurs, well diversified, hardly suffer from this crisis. Pangea is in full fragmentation. The mid-oceanic rifts are active and raise the average sea level. The continental zones split up, while the coastal zones are expanding. The Earth undergoes sudden climatic changes from cooling to warming 182 million years ago, following a volcanic episode producing large outpourings and strong methane degassing. Changes in ocean currents added to this already unbalanced context for life. Exchanges between cold and warm waters are decreasing, as well as the oxygenation of the ocean floor. This small crisis has mainly an impact on marine organisms, but it remains less dramatic than the mass extinctions. As a result of various specific evolutionary innovations, some species of dinosaurs become feathered. In addition to their role of thermal insulation, feathers of different colors allow to install a communication by visual signals or to protect eggs. They have a significant locomotor role. Some dinosaurs began to fly, colonizing new ecological niches, escaping their predators more easily and improving their hunting abilities. Large lava emissions shaped large plateaus and announced the separation of South America and Africa, which were still fused together. 10 million years later, a flood occurs, sign of the fracturing of the two lands, which will become the South Atlantic Ocean. 11:49 a.m. End of the Tertiary Era. Cretaceous-Paleogene extinction. 66 million years ago, in a magmatic province of western India, huge lava flows, called The Deccan Traps accumulated. The succession of eruptions allows the accumulation of lava sheets up to 2,400 meters, or 8,000 feet thick. The repercussions of the latter on the environment and the climate are major. Large quantities of water vapor, sulfur dioxide, and CO2 are released into the atmosphere. The water vapor turns into white clouds and becomes a powerful greenhouse gas. Sulfur vapors turn into acid rain, and CO2 is a greenhouse gas. Organisms are unable to adapt to these climate changes. At the same time, a meteorite pulverizes on the Earth, creating an impact crater of 180 kilometers, or 111 miles in diameter, on what is now Mexico. Its components scattered in the atmosphere and fell in different places, creating a composition anomaly. An abundant amount of dust rises, creating a shield to the sunlight, and an almost permanent night, similar to an artificial winter. The Cretaceous-Paleogene crisis, formerly known as the Cretaceous-Tertiary, occurs at the same time as these latter events. Although not the most catastrophic of the 5 great extinctions, causing the loss of only 6% of the species living on the continents, it remains the most significant for the non-avian dinosaurs that disappeared. As for marine species, 76% of their species have become extinct. This extinction has a strong impact on biodiversity. Some species disappear, leaving the field free for others, such as small mammals, to diversify and develop. This transition from the world of ammonites and reptiles to that of mammals and fish is done in a brutal way. At the beginning of its fragmentation, Pangaea separated into 2 blocks, Laurasia and Gondwana, which contains the plate which will constitute India. A few million years later, a hotspot volcanism separated India from South America, until sometime later, a sea passage separated them. India continues its course, and 65 million years ago, in the middle of crossing the Tethys Ocean, it passes over a hotspot volcanism, which accelerates its movement. India then moves northward until it violently collides with the present Asia. This violent collision gave birth to the Himalayas on the surface and to particular minerals such as the Burmese emeralds in its depths. A climatic crisis occurs, resulting in hyperthermal episodes, the major one being called the Paleocene-Eocene thermal maximum. This event is due to the thermal destabilization of the methane hydrates present in the sediments, which leads to a significant release of methane into the atmosphere. The temperature of the deep ocean warms up by about 5 degrees Celsius, or 41 degrees Fahrenheit, and reaches 10 degrees Celsius, or 50 degrees Fahrenheit. Surface waters are around 23 degrees Celsius, or 73 degrees Fahrenheit, and the Arctic is 20 degrees Celsius, or 73 degrees Fahrenheit. This general warming disrupts the carbon cycle and is accompanied by a biological crisis with the extinction of about 40% of the species of benthic foraminifera and the appearance of the major orders of modern mammals. Titanoboa, a cold-blooded reptile weighing up to 1 ton, appeared in this warm and humid environment. In eastern Africa, plate tectonics is at work. The Arabian, Nubian, and Somali plates pull apart to form the Great Rift Valley, deep collapse furrows measuring more than 6,000 kilometers, or 3,700 miles, for an average width of 50 kilometers. 35 million years ago, India drifted and violently collided with Asia, leaving a huge mountain range as a result of this collision. During the collision, continental blocks were ejected, and large faults propagated, dividing the heart of the continent and driving two parts towards the Pacific. The consequences of this collision, a few million years later, is the formation of two peninsulas, Malaysia and Indochina. Plate tectonics opens the Drake Passage between Tierra del Fuego and Antarctica, and the Tasmanian Passage between Australia and Antarctica. 35 million years ago, these openings deepened and created a current, the Antarctic Circumpolar Current, which thermally isolated Antarctica. This current, combined with a decrease in atmospheric CO2, thus reducing the greenhouse effect, causes the total freezing of Antarctica. Formed by the accumulation of volcanic rocks, the island of Iceland emerged from the waters 24 million years ago. The volcanism of the island began 30 million years earlier, during the separation of northern Europe and Greenland. Iceland is part of an underwater mountain range, with landforms measuring 3,000 to 4,000 meters, or up to 13,000 feet. A caldera is a large depression equivalent to the collapse of a magma chamber that has been emptied during an eruption. The Yellowstone caldera was formed 17 million years ago when the American plate was placed over a hotspot. The scene of gigantic eruptions where heat is evacuated in the form of geysers, this immense volcanic apparatus is inhabited by organisms that adapt to the extreme living conditions. 7 million years ago, the oldest known hominid appeared. His name, Tomai. More than 350,000 generations separate him from our time. The most complete skeleton that has ever been found to date is 3.2 million years old. 52 bones of a female Australopithecus, who was named Lucy. Female, she died when she was only about 20 years old. She is about 1.10 meters or 3.6 feet tall and weighs 25 kilograms or 55 pounds. According to her postcranial skeleton, she is bipedal and has an aptitude for arboreal life. It was first considered as the ancestor of modern man, but finally relegated as a cousin of our lineage. 11:59 a.m. Quaternary glaciations. The Quaternary era began 2.6 million years ago. It is the most recent period on the geological timescale. It is marked by glaciations and by the evolutionary radiation of the Homo genus. At least 17 periods of glaciation followed one another, separated by interglacial periods. This succession of climate changes generates cycles of extinction and recolonization of environments and diversifies species. Ice sheets are formed on the continents, shaping the landscape through the phenomenon of glacial erosion. A transfer of mammals occurs between South America and North America, called the Great Inter-American Exchange, following the closure of the Isthmus of Panama. Porcupines, anteaters, and armadillos move north, while horses, deer, elephants, and raccoons move south. This phenomenon is quite balanced at first. After a million years of mobility, the northern mammals continue to live and migrate south, while those originating from the south become extinct or are few in number. 2.5 million years later, only 10% of the northern mammals are of southern origin, while half of the southern fauna is of North American origin. A new genus of bipedal hominids appears, quite distinct from the genus of Australopithecus already present on Earth. It is the genus Homo. Homo habilis is the first representative species of the genus 2.4 million years ago in Africa. Several species will then appear distributed on the different continents. Homo rudolfensis and Homo ergaster are only of African origin. Homo neanderthalensis is known throughout Eurasia. All are characterized by a constant bipedalism, an increased cranial capacity, and cultural activities such as funeral rites or artistic creations. 12 p.m. minus 10 seconds. Appearance of Homo erectus. Homo erectus appears in Africa, but he will later conquer a large part of Eurasia and Indonesia. He built huts and improved carving techniques. It is at the origin of new behaviors in the human lineage because it adapts greatly to human needs and local living conditions. Long before they domesticated it, the representatives of the Homo genus used fire, which arose naturally from lightning, and exploited it spontaneously. 1 million years ago, hominids used fire and benefited from all its advantages. First of all, it was used for cooking for better taste, and also to eliminate pathogens potentially present in food. Fire also served as a weapon of protection against wild animals or between populations. Not to mention the heat and light it provides, opening the door to the beginning of a social life. 12 p.m. minus 6 seconds. The disappearance of Homo erectus. Despite the great progress made by Homo erectus thanks to its tools, its capacity for innovation and adaptation is not sufficient to maintain itself and evolve on Earth. The Neanderthal Homo enters the history of the human race a little over 250,000 years ago. First appearing in Europe, he later occupied all of Eurasia. It is physically smaller and more massive than Homo sapiens. It is distinguished by a thickening of the bones above the orbits, a receding forehead, and the absence of a chin. His brain, larger than ours, does not indicate that he was different from us in terms of intellectual capacities. He bequeathed to modern man a part of his genetic heritage, which suggests that Neanderthal man and Homo sapiens were so close that they reproduced at some point. 12 p.m. minus 5 seconds. The appearance of modern man. The human lineage differentiates itself a few 100,000 years ago with the appearance of Homo sapiens. He is the only current representative of the Homo genus. From a physiological point of view, it is distinguished by its rounded and voluminous skull, the absence of a supraorbital bulge, a prominent chin, and a minus developed pilosity. Its locomotor mode on the ground is entirely bipedal. Homo sapiens is also distinguished by the existence of social relations and a complex articulated language, and by the wearing of clothes. He developed techniques to domesticate nature. He colonized all the continents except Antarctica. The first burials appear more than 100,000 years ago. People now pay intentional attention to their dead and bury them instead of simply disposing of them. Given the small number of documented burials, we can assume that Neanderthals and Homo sapiens selected who they buried. The appearance of burials causes a poor preservation of cranial boxes over time. Previously, they were kept in the habitats of their relatives and were found in better condition. A fragment of an iron meteorite about 20 meters in diameter crashed to Earth in Arizona at a speed of 50,000 kilometers per hour, or 30,000 miles per hour. Its impact crater, named Meteor Crater, is a little more than a kilometer in diameter and almost 200 meters deep, or more than 650 feet deep. The energy released during the impact is colossal. 150 million tons of rock are ejected and spread over 260 square kilometers. The shock wave sweeps and pulverizes everything within a radius of about 15 kilometers. The area will be recolonized by organisms in 1 year. The disappearance of Neanderthal man is not yet well known. One hypothesis would be that the latter would have disappeared gradually following the arrival of groups of modern men, nicknamed Cro-Magnon men. A competition on the territories for the exploitation of the resources takes place, and violent conflicts ensue. The domestication of the dog for hunting by Homo sapiens coincides with the disappearance of Neanderthal because it would have given a strong advantage to the first in their search for food. At the end of the last ice age of the Quaternary, the fauna and flora developed. Some human populations settle down and take an interest in new activities such as ceramics, pottery, or agriculture and breeding. The oldest focus of agriculture developed in the Fertile Crescent, a geographical area of the Middle East, irrigated by the Jordan, Euphrates, Tigris, and Nile rivers. Societies became more complex, hierarchical, and organized, since they now held stocks. 9,000 years ago, the Bosphorus Strait was formed between the Asian continent and the European continent. The waters of the Sea of Marmara flowed into the Black Sea, which was until then a freshwater lake 30 to 100 meters deep, or about 300 feet. The Sahara, the largest hot desert in the north of the African continent, offered a completely different scenery in 6000 BC. The 8.5 million square kilometers that it covers are at that time green. Like a gigantic tropical savanna, gazelles, hippos, and elephants came to drink around the lakes in place. This is the last green episode, or wet African period, that the Sahara will experience, which is linked to the beginning of the interglacial period during which abundant rainfall wets the region. From 5500 BC, a climatic change occurs and the rains become rare. Sand gradually covered the entire Sahara, and tropical species gave way to species adapted to desert conditions. With the development of agriculture and trade, it becomes essential for men to find a memory system that goes beyond the present moment. It is in this sense that writing appears, which marks the end of prehistory and the advent of history. It is in Mesopotamia, a historical region located between the banks of the Tigris and Euphrates rivers, in the heart of present-day Iraq, that the first traces of writing were found, around 3500 BC. Men used small tablets to note the name of the owner and the quantity of goods. Far from a writing based on an alphabet, the oldest found supports are in the form of signs like pictograms and ideograms. Gradually, the Sumerians developed techniques to produce more advanced writing, the cuneiform writing, which is translated by wedges interlocked with each other to give birth to signs. It was not until the 14th century BC that each sign corresponded to a letter. Although writing appeared in Mesopotamia a few centuries earlier, other peoples developed their own writing systems. The Egyptians, among others, developed hieroglyphs, sketched on papyrus rolls or leather. This figurative writing system represents objects such as plants, animals, or human and divine figures. In ancient Egypt, men are subjected to the annual overflow of the Nile and decide to develop the very first calendar. The Egyptians observe that the beginning of the flood coincides with the day when the brightest star in the sky is seen in the glow of the rising sun. They then determined this day as the first day of the year, which was then divided into 3 seasons in order to control time and to give rhythm to agriculture. Although imperfect, this calendar remained for millennia before being reformed by Julius Caesar. The site of Stonehenge, located in the south of present-day England, is established. Sanctuary of a solar cult, funerary monument, and astronomical observatory, this site sees in the year 2400 BC rise its first large stones in the form of a perfect circle of 33 meters in diameter. That is to say, 108 meters in diameter. This historical monument uses astronomical knowledge and serves, among other things, to observe the position of the sun in order to establish a solar calendar. 3,600 years ago, the volcano of Santorini, located in the Aegean Sea, erupts. It takes him barely 100 years to wake up. This explosion generates up to 60 cubic kilometers of magma in the form of a fiery cloud. Pumice stones and ashes are projected to 900 kilometers or 560 miles around. The explosion destroys the island and the volcano collapses on itself. A caldera is formed, and a gigantic tsunami crosses the eastern part of the Mediterranean Sea. In 400 BC, a first thinker asserts that the Earth is not immobile, nor at the center of the universe. Philolaus of Crotone, an astronomer, mathematician, and philosopher, considers the Earth as a planet that rotates around the central fire, different from the Sun, and located at the center of the universe. He is the father of the heliocentric system. For him, the Sun, the Moon, and the 5 visible planets are in rotation around this central fire. The most famous volcanic eruption of Vesuvius took place in the year 79 AD. At first, large explosions are generated by the contact of water against the magma that is vaporized. A little later, the plug of lava is pulverized, ejecting fragments to more than 30 kilometers high. Every hour, 15 centimeters or 6 inches of ashes and pumice stones accumulate, until collapsing under its own weight and falling back in a pyroclastic cloud. Various explosions occurred and ruined Herculaneum and Pompeii. The word volcano appears. In 1257, on the island of Lombok, Indonesia, Somalis erupted and will remain the most devastating volcanic event known to date. Following the eruption, the volcanic ash reflects the sun's rays and causes temperatures to drop. This brief cooling has harmful consequences on the populations. A new look at the universe and the position of the Earth and man in it in 1543. Scientific methods and philosophy evolved from a geocentric to a heliocentric representation of the universe. The work of The Revolutions of the Celestial Spheres, written by Nicholas Copernicus, appeared, although it had been completed 13 years earlier, but fear of the reactions of the Church and the state delayed its publication. The real novelty of this work is that Copernicus placed the sun at the center of the system, and that he made the planets, including the Earth, rotate around it. The Copernican revolution changes the representation of the world compared to what it was in the past. Mathematics now has a special role in describing the physical laws of the universe. "12 p.m. minus a few hundredths of a second. The Earth continues to move. On May 22, 1960, a mega-earthquake took place in Valdivia with a magnitude of 9.5, the highest that has ever been recorded. The cause was the sliding of the Nazca Plate under the Chiloa Block at a depth of about 18 meters or 60 feet. The ocean floor rises 6 meters or 20 feet at this point and creates a tsunami on the whole Chilean side. This tsunami then travels across the Pacific Ocean until it reaches Hawaii and causes impressive damage with waves of 10 to 12 meters or more than 40 feet high. Then the tsunami reaches the coasts of Japan, New Zealand, the Samoas, the Philippines, and the Marquesas Islands. The Chilean coast was deeply modified, and the mega-earthquake caused about 4,000 deaths and 2 million homeless. On May 24, 1960, 2 days later, the Cordon Col volcano, located in the south of Chile, in the Andes, erupted after more than 25 years of inactivity. 200 million cubic meters of lava flows were produced, and 60 million cubic meters of tephra were ejected into the air. 12 p.m. The Earth of today. Today, the Earth remains the 5th largest planet in the solar system by its diameter and mass. It orbits the Sun in 365 solar days. Its axis of rotation, inclined at 23 degrees, causes the parade of the 4 seasons. The Moon, its only natural satellite, is located at 384,000 kilometers from it, that is, 236,000 miles. The tectonic plates that make up the lithosphere continue to move a few centimeters every year. 71% of its surface is covered by water, in the form of oceans, lakes, and rivers. Its polar regions are largely covered by ice. More than 7.9 billion people live on Earth and depend on its natural resources. The evolutionary history of life has been punctuated by periods of expansion and mass extinction, which is why 99% of the species that once lived on Earth are now extinct. The history of the Earth is not like a long, quiet river. The forces of nature do not give our blue planet any respite, disrupting each time the equilibrium that had been set up. Today, human activity is adding to the forces of nature, leading to a loss of biodiversity, a climate crisis, and ecological excesses. Whereas in the past, man was a pawn in the geological phenomena, his activity today has an influence on the future of the planet. Is the history of the Earth over? No, the continuation still seems very long, and even if our knowledge allows us to predict certain events, it contains the unexpected. We have written the history of the Earth up to 12 o'clock. See you in the future to discover what the second part of the dial has in store for us.